We had started with chapter number 10. We have discussed a few theorems. Exercise 10.4, this is the one we have to start. The last time we were discussing this result, that the chords which are equal, they are equidistant from the center. And if the chords are equidistant from the center, then the chords are also equal. So if you have two equal chords, A, B, C, D, the perpendiculars that we will draw from the center to the chords, they will be equal. And if those perpendiculars are equal, the chords themselves will also be equal. Second thing we know about the fact is about a perpendicular which is drawn from center to a chord. अगर हम center से chord पे perpendicular draw कर रहे हैं, that perpendicular is going to bisect the chord. So all these results will be used in one way or the other, or sometimes together in the questions that we have in 10.4. So please remember this. अगर आपको किसी chord का distance देखना है center से, we need a perpendicular from the center to the chord, and that perpendicular which we have drawn or constructed from the center to the chord is going to bisect the chord. And in case we are dealing with two chords which are equal, then those perpendiculars drawn from the center onto those respective chords will be equal, and conversely is also true. You don't have to write down the theorems, you just need to remember these results. The ones whose proof is given in the book, the ones for which I have made you write down the proof properly, only those are to be done. So I think there's just one theorem 10.1 that we have done till now. उसका proof आपके syllabus में है, और एक theorem अभी इसके बाद आएगी, इस exercise के बाद उसका proof है. उसके अलावा कोई theorem नहीं है. You can always cross check the syllabus given by CBSE just to be sure कि कौन सी theorems करनी है. I think I made it clear. Geometry में हमेशा वो वाली theorems होंगी syllabus में जिनका proof book में लिखा होता है. Like after the theorem, proof बनाकर proof दिया होगा, heading बनाकर proof. So those are the ones which are usually done. But this year, I think उसमें से भी कुछ theorems delete हो गई हैं. इसमें सिर्फ दो ही हैं, 10.1 and I think the next one I think. The angle subtended by a chord is based है. From exercise 10.4, it's on page number 179. Please mark question number 5 and 6 are deleted. So we shall be doing the first 4 questions. Out of these first 4 questions, the first question is to be done with the help of construction. So you simply need to draw this. We will come back to it afterwards. So I'm going to do question number 4th first of all. Reverse order में चलते हैं. Question number 4th. If a line intersects two concentric circles with the same center, so you should know what concentric circles are, the circles with the same center but different radii. So we have this figure here, 10.25. You can see there are two circles. O is the center, and there is a line. Let us name this line on our own. Let's say this is line L. So line L actually intersects both circles. अगर हम larger circle की बात करें, points of intersection है A और D. The line L intersects the larger circle at points A and point D, and the same line intersects the smaller circle at points B and C. You want to prove that AB equals to CD. The segments of this line between the boundaries of the two circles. Circles की जो boundaries हैं, उनके बीच में इस line के जो हिस्से lie कर रहे हैं, वो equal हैं. So sometimes the question could directly be in statement form, that if a line intersects two concentric circles, prove that the segments of that line lying between the boundaries are equal. So this is what you will have. So we want to prove AB equals to CD. Since if you look closely, these are two circles with different radii. We have points on the boundary. So for the smaller circle, you have BC as the chord. I hope you know definition याद होगी chord की आपको. Chord is a line segment which joins two points on the circumference. तो smaller circle की बात करें तो BC is the chord. Points B and C are lying on the boundary, so BC is the chord for the smaller circle. Whereas AD is the chord for the larger circle. So I would be using construction here. I'm going to construct a perpendicular from the center to this chord. So whether it's the smaller chord or it's the larger chord, means rather I should say chord to the smallest chord in smaller circle, or it is a chord in the larger circle. जब आप center से perpendicular draw करोगे, चाहे वो छोटे सर्कल के लिए करो, चाहे वो larger circle के लिए करो, same होगा. So we will just say that we are constructing a perpendicular to line L from the center. So looking at the smaller circle, just focusing that this is line L, this is the smaller circle, and हमने O से perpendicular draw किया है. And since BC is your chord, OM is perpendicular from the center, what will it do is it will bisect BC. You have this theorem, perpendicular from the center bisects the chord. So you will have BM equals to MC. A similar result can be obtained in the larger circle as well. So I will just draw roughly here a larger circle. So let us say we have the larger circle. Same line. Now this line L intersects the larger circles at points A and D, and O is the center, और हमने already इस पे perpendicular draw किया हुआ है. Now in the larger circle, the chord is AD, and OM is perpendicular to this chord from the center. So this will bisect the chord. And you will conclude from here that AM equals to MD. These are the two results which we have obtained with the help of what we constructed here. Anyone with questions still here? You're going to write this down, but let me know if you understand what I've done here. Now, just one step and you will know what was the purpose of doing this. I've got two results because of this perpendicular. Both the chords of the smaller circle and the larger circle are bisected. I've got these two results. So I'm going to now subtract the two. The parts of the larger chord minus the parts of the smaller chord. So AM minus BM. On the right hand side, MD minus MC. So focus on the figure given in your book and try to observe what will happen if I do this. AM, ये line segment है. इसमें से अगर मैं BM remove कर दूं, what am I left with? AB. On the other
equals
side,
to DC.
Yeah, on the other side, I'll be left with DC, and that's what I wanted to prove. So that was the intention of constructing that perpendicular to the chords. I get two halves for each of the chords, and then subtracting the parts, I get the required answer. Shall we write down? Maybe you've already done. You can do this now on your own. Let's write it down. So this is exercise 10.4, page number 179. Question 5, 6 are deleted. And question number 1 we'll do at the end. You could even try question 1 actually on your own. So question number 2, I need concentric circles. Let's just draw. So in given, usually you just have to describe what's happening in the figure. So line L intersects the circles at A, B, C, D as shown in the figure. We want to prove that AB equals to CD, and this requires construction. I'm not specifying the chord for any of the circles. I'm just writing down that the perpendicular has been drawn on the line from the center. In our proof, we will be referring to the two circles separately. In smaller circle, BC is the chord and OM is perpendicular to BC. So you can simply write down that BM equals to MC, and you can write down perpendicular from the center bisects the chord. And let's mark this as number 1. Same reason, perpendicular from the center will bisect the chord. Always be careful when you are subtracting two results as such, where you are just referring to the names, not measurements, which one is larger, which one is smaller, so that you're writing it correctly. So on the left hand side, I will have AM minus BM. On the right hand side, I will have MD minus MC. This will give me AB equals to DC, which is the result I wanted to prove. Let me know once it's done, then we'll take up the next question.
Ma'am, it's question number 4. You have written question number 2.
Oh, yeah. I'm sorry. Thank you. Let me just change it. This is 4th question. Yeah. Thank you. Okay. I hope you have written. Shall we start with the next one?
Yes, ma'am.
Question number 3rd here. Along with this, I would like you to keep in mind that the example before this exercise, example number 2 and question 3 of the exercise, they are kind of converse of each other, kind of. So what you have here is there are two equal chords in a circle. They are intersecting within the circle. So two chords, you have to draw two chords. The chords must be intersecting, and keep in mind those chords are given as equal. You have to prove that the line joining the point of intersection to the center. So you will have a point of intersection of the chords. You will join that point to the center. And what will happen is an angle is formed by that line that joins the point of intersection to the center with the chord, with each of the chords. You have to prove those angles are equal. Let's just draw a rough figure here so that it's easier to understand. So I have a circle with center O. I have drawn two chords AB and CD. These are equal. So length of AB is same as length of CD. What are the results which can be concluded just by looking at two equal chords in a circle? अगर हमारे पास किसी circle में दो equal chords हैं, क्या क्या conclude किया जा सकता है? The angles which
perpendiculars.
Yes, I'm just going over from the beginning. That's actually the one we will use here. If we have two equal chords in a circle, the angles these chords obtained at the center will be equal. That was your first theorem. Second one, if you draw perpendiculars from the center, The purpose of drawing the perpendiculars is to measure the distance. कि ये chords center से कितनी दूर हैं. The distances of both of these chords will be equal. तो अगर मैं दोनों chords पे perpendicular draw करूंगी तो वो दोनों perpendiculars equal होंगे. That's the second result. But उस केस में जब मैंने perpendicular draw किया, वो perpendicular chords को bisect भी करेगा. Since the chords were equal, इनके halves भी equal होंगे. So see how all these results are working simultaneously. At the same time सब कुछ apply हो रहा है. Chords equal हैं तो इनके perpendicular distances from the center will be equal. But जब भी हम center से perpendicular draw करते हैं, chords bisect हो जाती हैं. इस केस में क्योंकि chords भी equal हैं, the total length is same. जब उनकी bisection होगी by the perpendiculars from the center, those halves will also be equal. Just a point to be kept in mind whenever you have such a question, because example में भी ये use होता है, I think something like that, and in question number 2, all these results. Now, right here, they are saying that if the point of intersection is E, suppose, let's join this point of intersection to the center. And as you can see, this line segment EO makes an angle with chord AB. This is the angle with AB. And there is angle formed by the same line segment with the chord CD. You have to prove these angles are equal. This is what your question is. You could also write down angle OEB equals to angle OED. And what we will do is, I think Manya referred to that perpendicular thing. So we will be constructing perpendiculars from the center onto the chords. So let's construct perpendiculars. Perpendiculars from the center. OM is your perpendicular to AB and ON is perpendicular to CD. Let me just erase this so that it's convenient to see what's happening here. So this is what I have. I want to prove angle 1 equal to angle 2. So I would like to prove the triangles containing angle 1 and angle 2 congruent to each other. And by CPCT, I would be able to write down angle 1 equals to angle 2. Can we prove that?
Yes, ma'am. By RHS.
By RHS, because we have an angle 90 degree, right angle बन रहा है हमारे पास, एक common side है, and since the chords are equal, the perpendiculars from the center will also be equal. These will be equidistant from the center. By RHS, the two triangles will be congruent, and hence you will be able to write down angle 1 equals to angle 2. जो एग्जाम्पल है उसमें कन्वर्स है, आपको दिया गया है कि ये जो एंगल बनता है ये इक्वल है, एंड यू वांट टू प्रूव दैट द chords are equal. So try going.
Excuse me, ma'am.
Yes.
Ma'am, can we suppose that E and O coincide an equal chord and equal angle at the center, so the angles will be equal?
In that case, I mean, you are saying point of intersection is the center?
Yes, ma'am.
Okay, you could also say that, but that will be special case. That will be a special case. आप वो mention कर सकते हो in case, because this is something that occurred to me. If we consider that the point of intersection of the chords is the center, then the chords will actually be the diameters, right? Do you
Yes,
yes,
that,
ma'am.
right? Yeah. So
Yes, ma'am.
in that case, obviously the angle at the center is going to be equal. But that's the special case of chord when it passes through the center. So we are not talking about that particular case. Whenever you have to prove a certain result, तो अगर वो chord लिख रहे हैं तो हम उसको as a chord consider करेंगे, not necessarily that particular case when the chord passes through the center and becomes the diameter. Although that can be concluded, but उससे हम इसका proof नहीं कर सकते justify. This works for any kind of chord. Doesn't matter how it's drawn, how short it is, how long it is, doesn't necessarily passing through the center. But that's a conclusion that can be drawn, like obviously it could be asked to you, like पूछा जा सकता है. That's good aptitude kind of thing can be, concluded. I hope this question is clear. I would like you to do the example 2 after the class, like after you have your classes today. Just go over that example. There is just one thing in that example, the way they have proved the congruence, they have, I think, done something to use those two angles. तो वो ध्यान से देखना आप. You can simply use AAS. उन्होंने ASA use करने के लिए थोड़ा सा ऊपर extra काम किया हुआ है. So just go over that. You will know what I'm talking about once you go over that. Think of this figure. Think of the congruence, because आपका जो conclusion आएगा वो congruence की help से आएगा. So while doing that example, keep in mind कि आपको triangles को congruent करना है, and what's the best possible rule to do that. Don't follow what's given in the book, because उन्होंने बहुत extra काम किया है और उसकी जरूरत नहीं है. Let's do this. Question number 3. Now, the two questions that we have just discussed, the previous one and this one, I actually didn't require the radius. So I am just writing down that I have been given a circle with center O, but you can always name your circle the way I have told you. Circle in the brackets, center comma the radius, and you can write down the radius R for this one also, doesn't matter. Although we will not be using it in any of our proofs. AB equals to CD. These are the chords. You can write down chord AB equals to chord CD. Just to specify कि हमारे पास chords हैं. If you want, you can just number these. I think that will be convenient. Angle 1 equals to angle 2. And again, we will be doing some construction here. From the center, we are drawing perpendiculars onto the chords. So OM perpendicular to AB and ON perpendicular to CD. You can conclude before writing the congruence. Congruence लिखने से पहले आप ये conclude कर सकते हो कि chords equal हैं तो perpendiculars भी equal होंगे. Or you can do the same while writing down the congruence pairs. Like I'm doing it simultaneously. So I'm taking the two triangles, triangle OEM and triangle OEN. The first thing that I can see is OE equals to OE. Don't use angle 1 equal to angle 2. वो prove करना है. That will be written after the congruence by CPCT. Another thing that we have is OME equals to ONE. These are 90 degrees each. And then finally you have OM equals to ON. Since the chords are equal, the perpendiculars from the center to those chords will also be equal.
At 28 is F33. This is grouping chord and this is uncovered. Thank you.
Any questions? अगर इसका converse करना हो, similar thing, we will be proving the congruence of the two triangles. Now in that case, angle 1 will be given equal to angle 2. What do you think will get interchanged in the to prove and the proof part?
The right angle.
The right angle. No, actually the right angle will be from the construction. That will be there. वो तो करना पड़ेगा.
And we will prove congruence by AAS.
Yes, the congruence will be proved by AAS. You will have angle 1 equal to angle 2 in given. आपके पास right angle होगा. आपके ये perpendiculars equal नहीं होंगे. ये condition change होगी. Let me just... This condition और ये वाली condition interchange हो जाएगी. आपको प्रूव करना होगा AB equals to CD. गिवन होगा एंगल 1 equals to एंगल 2. क्योंकि कॉर्ड्स इक्वल नहीं है इसलिए ये चीज नहीं होगी. इंस्टेड ऑफ दिस यू विल बी यूजिंग दिस. जो गिवन है हम वो यूज करेंगे. एंड बाय CPCT you will have OM equals to ON, which will imply that the chords are equal. Construction same होगी. You will need these perpendiculars. और इन्हीं की help से chords equal prove होंगी. If you can prove that the perpendiculars from the center to the chords are equal, the chords will also be equal. So that's what you will do in that example. And the congruence will be with the help of AAS rule. Just do that. I think you will be able to do it now. Let's do question number 2. This is a little complicated than the last 2 questions that we have done. So you have been given that 2 equal chords. Question number 2 here, if 2 equal chords, again we have equal chords, they intersect within the circle. So let's say the point of intersection is E. Prove that the segments of one chord are equal to the corresponding segments of the other chord. इस केस में जब हम segments की बात कर रहे हैं, we are talking about the parts of the chord. When the chords intersect each other at point E, the chord AB is divided into 2 parts, AE and EB. AB के 2 हिस्से हो गए, एक smaller है in size, एक larger है in size, and the other chord CD also gets divided into 2 parts. One part is smaller and the other part is larger. You have to prove कि अगर वो chords originally आपस में equal हैं, the lengths of the chords are equal, then the parts, corresponding parts will also be equal. Means the smaller part of chord AB will be equal to the smaller part of chord CD, and the larger part of chord AB will be equal to the larger part of chord CD. So यहाँ पे आपको prove करना है AE equals to CE and BE equals to DE. This is what you want to prove. And the result will be actually concluded with the similar kind of proof we did in the previous question. We will need those perpendiculars from the center. So let us say O is the perpendicular. As such, हमें सिर्फ ये दिया हुआ है कि AB और CD आपस में equal हैं. So I'm going to construct perpendiculars from the center to these chords. And what these perpendiculars will do, they will tell me how far they are from the center, first thing. Secondly, these will be bisecting the chords. So OM will bisect chord AB and ON will bisect chord CD. AB के 2 हिस्से हो जाएंगे, CD के 2 हिस्से हो जाएंगे. Now what I would like to prove is, I'm going to consider these triangles over here. These triangles that you can see, I'm going to prove these triangles congruent. First of all, let us just focus here.
By RHS, they can be proved congruent.
Yeah, they can. Let me just. So this is what we have. We would like to prove the congruence of these triangles, and we have a common side, we have a right angle. What else?
Perpendicular equal.
Perpendiculars are equal because the chords are equal. So a common side, a right angle, and the perpendiculars are equal because the chords are equal. They will be equidistant from the center. The two triangles will be congruent. And conclude क्या करें जिसकी help से हम ये prove कर पाएं. So I'm going to conclude by CPCT. Once I have proved triangle OEM congruent to triangle OEN, and as we just discussed, this will be proved by RHS. हमें conclude क्या करना है? इस congruence के बाद हम क्या conclude करें जिससे हम ये वाला
EM
result
equal to
obtain?
En equals to Em.
EM equals to EN. These are actually the parts of the chords, not the ones we want to prove equal, but yes, these are the parts of the chord that we can see in the figure. EM is a portion of AB and EN is a portion of CD. So somehow with the help of this equality, I will be able to reach the one I need. And for this, I'm going to use this particular concluded इक्वालिटी. एक ये यूज करेंगे हम. दूसरा रिजल्ट हम यूज करेंगे कि क्योंकि हमारी कॉर्ड्स इक्वल हैं, since the chords we have here are equal, we can talk about their halves being equal. Or please remember, whenever we are talking about halves, you can only talk about halves of a line segment of an angle only if you have been given bisection happening for them. आपके क्वेश्चन में कहीं ना कहीं किसी चीज की वजह से लाइन सेगमेंट बाइसेक्ट हो गया या फिर एंगल बाइसेक्ट हो गए, सिर्फ उस केस में आप ये लिख सकते हो कि क्योंकि वो ओरिजिनली इक्वल थे तो उनके हाफ्स इक्वल होंगे. बिकॉज हाफ्स हो रहे हैं तो हम हाफ्स की बात कर सकते हैं. अदरवाइज इट्स नो पॉइंट ऑफ इंडिकेटिंग के हाफ्स इक्वल हैं अगर हम उससे आगे कंक्लूड ही नहीं कर पाएंगे. अब इस केस में ए बी के जो हाफ्स हैं, AM and MB will be equal to the halves of CD, which are CN and ND. These are the halves of AB and these two are the halves of CD. These will be equal. And I'm going to take the ones on the same side. Same side means E की तरफ जो lie कर रहे हैं. E की तरफ lie कर रहे हैं AM and CN. और दूसरे वाले जो parts हैं उनको मैं separate कर रही हूँ. Let me know if this makes sense कि मैंने यहाँ पे क्या किया. हमने triangles की congruence करनी है. Congruence से हमने conclude किया EM equals to EN. मैंने EM equals to EN इसलिए pick किया because I'm going to talk about the parts of the chords and EM and EN are actually portions of those chords. तो वो उसकी help से हम आगे काम करेंगे. Second thing, since my chords were equal और मैंने उन equal chords पे perpendiculars construct किए थे तो मेरी दोनों equal chords bisect हो गई हैं. इसलिए अब उन equal chords के halves की मैं बात कर रही हूँ. But halves को pair up करना है. दो halves AB के हैं, दो halves CD के हैं. Pair them up in such a way that the ones on the same side are together. So the ones which contain E, I have separated those, and the ones which do not contain E, I have separated those. ये जो ऊपर वाला pair है, ये E contain कर रहा है. AM and CN, both of these parts contain E, whereas MB and ND, they don't contain E, the point of intersection. Now I'm going to mark these as number 2 and number 3. Anyone with questions still here, what we have done? All right, after this, you just have to do one more step. What I'm going to do is I'm going to take the parts containing E, and from that, I'm going to subtract equation number 1. So equation number 2 minus equation number 1. AM minus AB and, sorry, it's EM. AM minus EM and CN minus EN. Observe from the figure and tell me what you get.
AE equals to
AE
CE.
equals to C.
And using the third one, I will be adding it with 1. So 3 and 1 are to be added. So MB plus EM equals to ND plus BEN. Observe and tell me what you get.
BE equals to DE.
So this will give you BE equals to DE. And that will prove the result that you want to prove.
We can also prove this using Pythagoras theorem.
By,
And
this
as
go ahead.
in the smaller triangle, and we can also create MOB and NOD.
Okay, from that side. Yes, you can do that. You want to construct this. Let me just do this. This one?
Yes, ma'am.
Yes, these will be radii, and then you can prove that these will be equal. That's also fine. Will those be, but those will actually prove the halves equal. Which triangles would you
And we
take?
can also prove in the smaller triangles.
The ones I have proved congruent?
Yes, ma'am.
Okay, you are saying that equation number 1 can be obtained with the help of Pythagoras theorem?
And as OE is a hypotenuse in triangles,
Mhm.
EMO and
Mhm.
ENO,
Mhm.
that is common, and then OM equals to ON. So perpendiculars are also equal, so bases will also be equal.
Yeah, that's what I'm saying. The result that I have proved here with the help of congruence, that can be done with the help of Pythagoras theorem. आप यही बोल
Yes,
रहे हो
ma'am.
ना? Yeah, you can do that way also. That will also be correct. अगर आप congruence नहीं करना चाहते, आप इससे भी कर सकते हो. And I guess the meeting didn't end at 40 minutes. So I guess you have your next class. We will be writing down the proof for this question tomorrow. And if you've understood, you can write this on your own. All right. I'll see you all tomorrow.
Thank you,
Thank you,
ma'am.
ma'am.
God bless you.
Thank you, ma'am.